Now we will discuss occurrence of metals. The Earth's crust is a major source of metals. Many metals are found in the Earth crust either in the free state or in the combined state. The metals which have low reactivity are found in the free state and they are said to be in the native state. The metals like copper, silver, gold, these are least reactive metal, they are found in their native state, that is free state in the Earth crust. Some other metals which are reactive, moderately reactive or very reactive, they are found in the combined state either as sulfides or oxides, etc. So, they occur in the combined state as compounds. Copper and silver are the metals which not only occur in the free state, in the native state in the Earth crust, but also in the combined state. In the nature, these occur in the minerals in the form of compound. In the Earth crust, they are found as compounds. So, these natural materials in which the metals or their compounds are found in the Earth crust are called minerals. The minerals have the metals in the combined state, and these minerals which have high percentage of metals and from which we can extract the metal conveniently and profitably, these minerals are called ores. So, the conditions are minerals should have high percentage of the particular metal, and from that mineral we can extract the metal by convenient process and in a profitable manner. So, those minerals are called ores. All ores are minerals, but all minerals are not ores. All minerals cannot be used as ores. So, from the ores which are found in the Earth crust in the form of rocks, metal can be extracted. Now, these ores which are present in the form of rocks first of all have to be mined, taken out, they should be crushed into the small pieces and then should be powdered. Now, these ores do not contain only the compounds of the metal, they are also found some impurities, the unwanted material, earthy material, soil, sand, rocky material which is found with the ore is called gangue, and this gangue should be separated from the ore, and this process of separation of gangue from the ore is called concentration of ore. Then only the further separation of metal from the compound can be done. So, concentration of ore you will study in detail in higher classes, and it can be done by various processes depending upon the difference between the physical properties and the chemical properties of the gangue and the ore, because the gangue and the ore have different physical and chemical properties, and that is taken into account to use the process for the concentration of ore. Extraction of metal from the naturally occurring mineral, that is ore, is called metallurgy. As right now we have discussed that in the Earth crust the compounds of the metal are found in the form of rocks along with the gangue. So, first of all the rocky material is mined and then crushed and then concentrated, that is separation of gangue is done from the ore, and then extraction of metal from the concentrated ore has to be done by using the various processes. Now, how the extraction of metal from the ore has to be done, it depends upon the reactivity of metals. Now, in the reactivity series we can divide the metals into three parts. like the metals which have very low reactivity, the metals which are moderately reactive, and the metals which are very reactive. The metals which are very less reactive, which lie right low in the reactivity series, are copper, silver, mercury and gold. So, in that case the extraction of metal can be done by heating in air. First of all, by heating in air, what happens, the sulfides of these metals get converted into their oxides, and this process of heating of sulfides in excess supply of air is called roasting. So, by roasting, first of all, sulfides are converted into the oxides. 2HgS plus 3O2 gives 2HgO plus 2SO2. This is a balanced chemical equation, and this mercury sulfide ore is also called by a common name called cinnabar. Now, then mercury can be obtained from mercuric oxide just by heating. We can get the mercury metal. Now, copper, as we have discussed earlier also, that it not only occurs in the native state, it also occurs in the combined state as sulfides. So, by roasting copper sulfide, that is by heating in excess of air, copper sulfide gets converted into copper oxide. This is the balanced chemical equation. 2Cu2S plus 3O2 gives 2Cu2O plus 2SO2. You should write the balanced chemical equation and do the practice of writing the balanced chemical equation, so that you do not make any mistake. Now, here the heating is done in the excess of air, roasting is done. After a considerable amount of copper oxide is formed, supply of air is stopped. Now, what happens? Here, when a considerable amount of copper oxide has been formed, air supply has been stopped, what happens? This copper oxide reacts with copper sulfide and copper is obtained, and sulfur dioxide gas is also formed. So, here copper oxide is reduced to copper, reduction of copper oxide has occurred. So, this is how we can extract the metals which lie low in the reactivity series, which are least reactive, just by heating. And now, we discuss the extraction of the metals which lie in the middle of the reactivity series, or we can say which are moderately reactive, like iron, zinc, lead, copper, etc. Occur as sulfides also and carbonates also. Carbonate is least reactive, but it also occurs as sulfide. Now, as we know, as we have just now seen that these occur as sulfides as well as carbonates. Now, it is always best to convert first of all these sulfides or carbonates into their oxides. Now, how this can be done? We will just now discuss. Sulfides are converted to oxides by roasting, that is by heating in excess of air. So, here again roasting is done. 2ZnS plus 3O2 gives 2ZnO plus 2SO2. Sulfur dioxide gas is also formed and zinc oxide is formed. But in the case of carbonates, roasting is not done. Carbonates are heated in limited supply of air, and this process is called calcination. So, carbonates are converted to their oxides by calcination, like zinc carbonate on heating in limited supply of air forms the zinc oxide, and carbon dioxide gas is also formed. Now, the next process is to obtain metal from the oxide, that is by reduction of oxides to metal. How we can reduce these oxides to get the metal, and reduction can be done by carbon. carbon can be used as reducing agent. So, here what happens, zinc oxide can be reduced to zinc by heating with carbon and we get zinc, and carbon monoxide also. Also, reduction of metal oxides to the metal can also be done by using displacement reaction, like manganese dioxide can be reduced to manganese by heating with aluminium. It is an exothermic reaction and a lot of heat is also generated, and balanced chemical equation is, it is very necessary to learn the balanced chemical equation. 3 MnO2 plus 4 Al gives 3 Mn plus 2 Al2O3. Another such reduction process is the reduction of ferric oxide by aluminium. Fe2O3 plus 2 Al gives 2 Fe plus Al2O3 and a lot of heat is generated. Now, this reaction is also called thermite reaction or aluminothermy, and this reaction is used to join the railway tracks when the railway tracks are broken. So, this thermite reaction is used to join the railway tracks or the cracked parts of a machine by using this, because in this reaction particularly a lot of heat is generated, due to which iron is formed in the molten state and which joins the railway tracks, broken railway tracks and the machine parts. So, thermite reaction is very useful in this way. Now, we will study extraction of metals at the top of the reactivity series. As you know, the metals at the top of the reactivity series are very reactive, and reduction of very reactive metals like sodium, magnesium, aluminium, calcium cannot be done with carbon. So, extraction of metals in these cases is done by electrolysis. Electrolytic reduction is done of molten chlorides or molten oxides. Carbon cannot reduce very reactive metals like sodium, magnesium, calcium, aluminium, because metals have more affinity towards oxygen than carbon. As you know, carbon also forms oxides with oxygen, and metals also form oxides with oxygen readily, but metals have more affinity. Meaning of affinity is more attraction. Metals readily combine with oxygen as compared to carbon. So, reduction of such metal chlorides or oxides cannot be done with carbon, and in these cases electrolytic reduction is used. Electrolytic reduction is done by the process called electrolysis. Electrolytic reduction of molten chlorides or molten oxides is done. In case of sodium, magnesium and calcium, molten chlorides are taken, and in the case of aluminium, metal oxide is taken in the molten state. So, let us just study how this electrolytic reduction is done. In the electrolytic tank, the molten salt is taken. Let us take in this case molten sodium chloride. 2 electrodes are immersed in this molten NaCl and connected to a battery, a source of electric current. The electrode connected to the positive terminal is called anode, and the electrode connected to the negative terminal is called cathode. So, cathode is negatively charged and anode is positively charged. In the molten state, sodium chloride exists as ions. Sodium chloride is in the form of sodium ions and chloride ions. So, when electric current is passed through molten NaCl, positively charged sodium ions are attracted towards negatively charged cathode and get deposited there. So, sodium is deposited at cathode. When sodium ions reach cathode, they accept one electron, and after accepting one electron, it changes to sodium atom. Chloride ions are negatively charged, so they get attracted towards positively charged electrode, that is anode. And here, by losing one electron, it forms chlorine atom, and two chlorine atoms form chlorine gas. So, at anode, chlorine gas is liberated. So, this is how the reduction of these metal salts is done by electrolytic reduction of those metals which are very reactive. Now, when metal is extracted from the ores, generally it is in the impure state. To obtain the metal in the purest form, refining of metals has to be done. So, what is refining? Refining is to get the metal in the pure state. Refining of metals is generally done by electrolytic refining. Again, electrolysis is the method which is used for refining of metals. So, here also let us take the case of copper. Now, for electrolytic refining of copper, the electrolytic cell tank is used, as we used in the earlier case, electrolytic tank, and the electrolyte taken is acidified copper sulphate solution. The electrodes immersed in the acidified copper sulphate solutions are: cathode is of course negatively charged, connected to negative terminal of the battery, is made of pure copper. So, pure copper is made cathode, and anode, which is connected to positive terminal, is positively charged, is made of impure copper. And when the circuit is completed, electric current starts flowing through this circuit. What happens? The copper ions, so copper ions will be attracted towards negatively charged cathode. So, copper ions will go towards cathode, and there they will gain 2 electrons and form copper. So, what happens at cathode? Let us see. Copper ions go towards cathode and gain 2 electrons and form copper metal. So, pure copper gets deposited on the surface of the cathode, which is already made of pure copper. In the solution there are copper ions, so these are going there. Now, what happens here at anode, because copper ions are going here, copper from the anode dissolves, and it dissolves and it forms copper ions by losing 2 electrons. So, what happens at anode? At anode, copper loses 2 electrons and forms copper ions, and these copper ions then move towards cathode and on accepting 2 electrons form copper. So, gradually what happens, as electrolysis continues, cathode becomes thick due to the deposition of pure copper metal, and anode becomes thin because copper is continuously dissolving in the solution. So, this is how we can get the pure form of metal. Now, we can study how the extraction of metal has been done of the metals which are very low in reactivity, the metals which are medium in reactivity, and those metals which are very reactive. With the help of this table, ore, as you have studied that ore is that mineral which is naturally found in the earth crust and from which the metal can be conveniently and profitably extracted. First of all, concentration of ore has to be done. So, concentrated of metals of high reactivity are taken and pure metal is obtained by electrolysis of molten chlorides or oxides. Now, in the case of metals of medium reactivity, which lie in the middle of the reactivity series, these metals of medium reactivity occur as carbonates or sulfides. In case of carbonate ore, calcination is done, that is heating of the carbonates in the limited supply of air to get the oxide of metal. And in the case of sulfide ore, roasting is done, that is heating of the sulfide ore in excess supply of air to get the oxide of metal. Now, from oxide of metal, the metal has to be obtained by reduction. So, reduction of metal oxide can be done with carbon or aluminium. The impure metal obtained is then obtained in the purest form by electrolytic refining. Pure metal is obtained. Now, we move to the metals of low reactivity. Concentrated of metals of low reactivity are taken. The sulfide ores are roasted, heated in excess supply of air to get the impure metal, and then by refining of metal we get the pure metal. So, this is the summary of extraction of metals of highest reactivity, medium reactivity and low reactivity. Now, we will discuss about corrosion of metals. You have studied about corrosion of metals in the previous chapter also. Now, we will discuss somewhat in detail about corrosion of metals. You must have seen that is silver objects, silver utensils, silver jewelry. When you bring it from the market, it is very shiny and very attractive, and if you keep it for some times, it becomes black in color, it gets tarnished. You must have thought about it, why, what has happened? Silver is least reactive metal, why it has become black in color? So, this is due to the reaction of silver with some substance present in the air, and that is hydrogen sulfide gas, due to which it becomes black in color, because it combines with hydrogen sulfide and forms silver sulfide. Copper is also least reactive metal, and copper utensils, copper statues, if anything of copper is made, it also becomes green in color on exposure to air for a long time due to the formation of carbonates and copper hydroxide. It combines with carbon dioxide present in air, moisture present in air, and form carbonates and hydroxides. Also iron, iron nails, iron objects, iron grills, iron doors, you must have seen if they are not properly painted, also get covered by a brown flaky substance, and all of you know it very well. It is called iron rust. It is also called rusting of iron, and in general it forms oxides. It called iron rust or rusting of iron. So, all these metals corrode, and the process is called corrosion. What is corrosion? The eating up of metals by the action of air, moisture and some chemical present like acid or any gas maybe on their surface, and it is called corrosion. Now, corrosion should be prevented because the metals are very precious, useful and used to make various things. So, it is necessary to prevent the corrosion, and iron is widely used to make the buildings, to make the bridges, to make various vehicles, and rusting of iron is a great problem which should be prevented and which can be done by various methods. Prevention of corrosion can be done by various methods. Now, have you ever thought why does corrosion occur? What are the conditions necessary for corrosion, or we can say rusting of iron? For this, a simple activity can be performed in the lab by taking 3 test tubes. In one test tube, water is taken, a normal test tube. So, at the top there will be air, and this is a fresh iron nail which is shiny, which is this iron nail is immersed in water, and this is a rubber stopper. So, this is first test tube. In the second test tube, boiled water is taken. When water is boiled, all the dissolved gases escape into the atmosphere. So, it does not have any dissolved gases in it, and then there is some oil is placed over this boiled water, so that the air cannot pass through it and cannot dissolve in water. And in this also a fresh iron nail is kept, and the rubber stopper. This is rubber stopper. In the third test tube, iron nail is taken and it is partly filled with anhydrous. Anhydrous means dry calcium chloride salt, and an iron nail is kept in this. Now, function of calcium chloride is to absorb the moisture present in air. So, there is no moisture in this test tube, and this is also then fitted with a cork, a stopper. These 3 test tubes are kept for some times. It is found that in the first test tube, the iron nail gets covered by a brown flaky substance. Iron nail has rusted. Now, in the first test tube, water is also there, air is also there, and iron has rusted. In the second test tube, water is there, but there is no air. So, iron nail does not rust, it remains the same. There is no rust or no flaky substance, brown colored flaky substance on the iron nail. In the third test tube, there is no moisture or air is there. Moisture has been absorbed by calcium chloride, and this iron nail also has not rusted. So, what does it indicate? What does it show? It shows that for rusting of iron, both air and water are necessary, air and moisture are necessary, which are always present in the air, which cause rusting of iron. In the second case, there is no air, and in the third case, there is no moisture, which clearly proves that both air and moisture or water are necessary conditions for rusting of iron. Now, as you already know that iron is a very precious metal used for construction, buildings, construction of buildings, construction of making of vehicles, bridges, and rusting of iron is a problem, great problem of concern. Rusting of iron should be prevented. Now, how can we prevent rusting of iron? When a metal comes in contact with air, it gets rusted. So, if we cut off the contact of metal with the air, the rusting of iron can be prevented, and this can be done by covering the surface of the metal by a paint. Now, paint cuts off the contact between metal and the air, and due to which rusting of iron is prevented. You must have seen iron doors and iron grills which you see in the house are generally painted. Why it is painted? Why are they painted? Because to prevent rusting of iron, or by oiling. Even the iron knives used in the house should be smeared in oil to cut off the contact between the knife and the air. So, by oiling, by greasing, by applying grease also same condition arises. Next is galvanizing. Galvanizing is covering the iron object by thin layer of zinc. So, iron deposition of galvanizing is the deposition of thin layer of zinc over iron surface. How it is done? The iron object to be galvanized is dipped in molten zinc. It gets covered with a thin layer of zinc. Now, you may think, how does zinc prevent rusting of iron? Zinc is a very reactive metal. Actually, zinc reacts with oxygen and forms zinc oxide, and it does not further react. Now, zinc react even when the zinc layer is broken, then also it prevents rusting of iron, because zinc is more reactive. It will react, iron will not react. So, galvanizing is a very good method. Galvanized iron sheets, GI pipes we call, or galvanized pipes which are used, are very good things which prevent rusting of iron. Then tin plating, chrome plating, that is plating the iron objects by tin or chromium. By the process of electrolysis, the iron can be prevented from rusting. Another method which we have studied is anodizing. In the case of aluminium utensils or aluminium statues, rusting is done, corrosion is prevented by anodizing. Now, aluminium, as you know, is a very reactive metal. It combines with oxygen and forms aluminium oxide. Aluminium oxide then protects the metal underneath from further corrosion, because aluminium oxide layer acts as a protective layer. Now, this has been used for the prevention of corrosion of aluminium metal by anodizing. The aluminium object to be anodized is made anode, and electrolysis of dilute sulfuric acid is done. Oxygen gas is liberated at anode, which combines with oxygen and covers the surface of the aluminium as aluminium oxide layer. So, by the deposition of this aluminium oxide layer, a thick layer of aluminium oxide, corrosion of aluminium can be prevented, and this aluminium oxide layer also can be dyed into various colors to make it look attractive. Another method for the prevention used for prevention of corrosion is alloying, making alloys. Making of alloys. What is alloy? Now, alloy is a mixture of various metals, two or more metals, or a metal and non-metal, metals and non-metals are mixed, mixture of metals and non-metals. Iron is a hard metal, but when it is in the pure state it rusts, one thing. Secondly, it immediately when it is hot it stretches. If carbon is added to it, it becomes very hard. So, alloying changes the properties of the metal. The properties of the metal changes when the alloy is made. So, what is an alloy? Alloy is a homogeneous mixture of two or more metals or metal and non-metal. How an alloy of a metal can be made? It is prepared by melting the primary metal and then mixing the other elements in it in a definite proportion to make the alloy. Then it is the mixture is then cooled to make the alloy. So, various alloys are made, not only of iron, but of aluminium also, copper also, gold also, and which improves the property of the metal, and not only prevents corrosion, but improves its properties. So, let us discuss some of the alloys. Iron rusts very easily, but when it is mixed with nickel and copper, it forms stainless steel. You must have seen stainless steel utensils at home. Steel does not rust. Copper alloys are brass. Copper pure form it will corrode, but when it is alloyed with zinc, it does not rust, its properties improve. It is used to make copper utensils. Another alloy of copper is bronze. It is mixed with tin. Bronze is used to make statues. Another alloy is solder. Solder is an alloy of lead and tin. So, it is an alloy of tin or lead, we can say. The melting point of this alloy is less and it is used for soldering purposes in the electric circuits, because this alloy melts easily at low temperature. All of you know aluminium is a very soft metal. It is light in weight also, but when it is alloyed with magnesium, it forms the alloy magnesium. So, it not only remains light in weight, it also becomes strong. So, it is used to make the parts of an aeroplane aircraft, because it is light in weight also and it is strong also. The alloys becomes very strong, properties change considerably. Another alloy is duralumin. It is another alloy made by mixing the metals aluminium, copper, magnesium and manganese. So, in this case also same thing happens. The alloy is not only light in weight, but very strong also. Gold, if 24 carats gold is the purest form of the gold, gold is very soft and 24 carat gold cannot be used for making the jewelry. So, it has to be alloyed, some impurities have to be mixed, it has to be alloyed with copper, with silver to make the jewelry. So, 22 carat gold is used, which contains 22 parts of gold and 2 parts of copper or silver. Now, if in the alloy one of the metal is mercury, the alloy is said to be an amalgam. In the past also, the ancient people also, they knew about some process to prevent rusting of iron. Iron pillar near Qutub Minar was built 1600 years ago, and it is still there like that, because those people, those iron workers, they knew about some process to prevent rusting. So, they made it resistance proof. The pillar is 8 meters high and its weight is 6 tons, that is 6000 kilogram. So, these are the various methods we have discussed for the prevention of rusting of iron as well as to prevent the corrosion of some other metals.